Let's see, we're doing Math 321. Final section. This is 12.1 goodness of fit section. Let's see what kind of problems we got here. Goodness of Z fits. So question one is what are the requirements? That's pretty good to know. At least all expected frequencies need to be greater than or equal to 1. And at least 80% need to be greater than or equal to 5. Those are the requirements. So every category needs to have a 1 in it at least. And then most of them need to have 5 or higher. So when we're looking at your guys' group data later, like to see if we can pull off a goodness of fit test to do like the categories, like the machine, like the console or machine versus play style or gender, we just got to make sure it'll meet those requirements. We can do it because once if it works, the computer does all the work, and you look kick-ass for doing one of the harder tests. A bunch of these other groups are doing lame ones like proportion equals blank, proportion doesn't equal blank, and then you guys step it up to like a goodness of fit test or chi-square test for independence, which has the same requirements. Good stuff. So this is a calculator assignment problem. They want you to go through and take 659 and multiply it by the probability. So do I have a calculator here? So 659 times 0.17 equals, let's do this where I have it open. It says round to 2 decimal places. That's good because that's all I could do. We're going to take 659 and multiply it by 0.36. Do 4? Yeah. $659 times 0.23. $51.57. Expected count is n times p. So that's all we're doing. That's it. That was a short problem. I like easy problems. That's just calculator work. A manufacturer of colored candy states that 13% of the candies in a bag should be brown, 14% should be yellow, 13% should be red, 24% should be blue, 27% should be orange, and 16% should be green. A student randomly selected a bag of colored candies. He counted the number of candies of each color and obtained the results shown in the table. Test whether the bag of colored candies follows the distribution stated above. So H naught should be that it matches our expectations, and HA should be that it doesn't. Yes, there is a short way of doing this. If you want the fast way of doing this, oh, there's not a fast way of doing this. I forgot that only works with equal proportions. But we're gonna need this in a bit, so. Well, I can. There's a quick way to find the total without getting out a calculator. And that's doing the goodness of fit test right away and saying equal proportions. And it'll spit out n. N is 385. So I got my n real quick, 385. So then we'll do the percentages. What's the percentage it saves? 385 times 0.13. So 50.05. Yellow is 14. So 385 times 0.14. 53.9. Red was the same as blue. So it had the same percentage, so I can just copy that one. Blue is at 24%. What is my N here? I forget. 385. Is that what I just did? Wait. Yeah, okay. 385 times 0.24 is 92.4. 385 times 0.2 is exactly 77. And 385 times 0.16 is 61.6. Okay. Now let's come over here and see what they want us to enter here. It says round to 2 decimal places, so the decimal places are already out. Down arrow doesn't work. All right. Tab works though. Those are the values I had. We'll click check answer. And continue. Now it wants the chi-square statistic to 3 decimal places. Now we can do the test. Telling you where the observed is and expected, we calculated. Notice it pops out our expected because, well, we typed that in. Chi-square is 18.7196 So to 3 decimal places, that is 18.720. Our p-value is really 3 decimal places when you know the machine's spitting out 4. Sneakies. So we come down to making a decision. This was 12.1, number 3. We had brown, yellow, red, blue, orange, green. My observed was 63, 65, 57, 59, 78, 63. My expected, the percentages were 0.13, 0.14, 0.13, 0.24, 0.20, 0.16. This added up to 385. So we used N times P to get our expected values. We had 50.05, 3.90, 92.4, 77, and 61.6. So we said our H naught was the distribution matches manufacturers. And HA is distribution doesn't match. We have a chi-square of 18.7. We have a p-value of 0.0022. Alpha, they gave us as 0.05. What decision should we make regarding this hypothesis test? What's the verdict here? It's too low. Reject the hoe, which means support HA. And HA is there. So our statement is there is sufficient evidence to support the claim that the distribution of colors does not match manufacturer's expectations. Those stated by the manufacturer.
What test did you use on StatCrunch to get?
So this is stats, goodness of fit. and then chi-square. It actually has the name right on the main tab.
Yeah.
Well, close to the stats tab. Thank you. Did you post on one of my YouTube videos? Recently, Michaela, I don't know what, I didn't even look at the last name. It said Michaela made a comment on a YouTube video and I'm like. Okay, this one's a pain in the ass, so we're gonna do this one too. So question number 4. Does the location of your seat in a classroom play a role in attendance or grade? 400 students in a physics course were randomly assigned to 1 to 4 groups. This is on the class seat location problem. I know you can't see what I'm writing, but you can see it on the screen up here. So group 1 sat 0 to 4 meters from those, so they're the front row. 100 students sat in the front area, the front 2 rows. Then 100 more students sat in the next 2 rows, basically. And then 100 more students sat in the next 2 rows. And back to the 5 back section had 100 students in the back. And they wanted to see if seat location, does it play a role in attendance or grade? So it says that for the first half of the semester, the attendance for the whole class averaged 83%. So if there is no effect due to seat location, we would expect 83% of students in each group to attend. The data shows the attendance history for each group. We have 100 students in each group. So we're just multiplying 100 by 83%. 100 times 83.83. If it was 83%, then 83 should have shown up for each group. Different than what they had, but this is what we got here. Wait, what?
I just did it. It wants you to multiply each group by the actual attendance observed.
Oh, the actual percentage of students that attended.
Yeah.
With mine, it's easy because it's 100. If the group isn't 100, you have more work to do, but if it's 100, it's just move the decimal twice. Motherfucker, it says, oh. Learn to fucking read, Jones. 84, 84, 84, 80. There we go. Let's try that. And so the hypothesis should be that the average attendance in each group is the same for H naught, and then it's different for HA. So we're gonna have new observed, new expected. I'm just gonna delete that. Reuse this shit. We had 84, 84, 84, 80. We had 83, 83, 83, 83. Stats, goodness of fit, chi-square. We have our observed and expected. It's handy to label them as what it's going to ask you. And we got a really high fucking p-value. 0.986. Holy shit. That's because our values are almost spot on. Is there a significant difference? No. We are not rejecting H0, so we're not supporting HA. H0 should not be rejected because the p-value of the test is greater than alpha. Then it goes, all right, for the second half of the semester, the groups were rotated so the group 1 students moved to the back of the class and group 4 students moved to the front. Then they took attendance for the second half and it averaged 70%. The data shows the attendance records for the original groups. So again, I need to multiply this by 100. So I'm literally, for me, it's 100. Yours might be different. Mine was easy. I got to just not use a calculator. $75, $69, $52. And my expected is now 70%. So there's a lot of deviation here. I suspect when I do the goodness fit test now, it tells me that my shit doesn't work. That we're going to reject H0. No, it's close. It's close. Look at that. It's really close. 0.050 to 3 decimal places. The p-value of the test was greater than the level of significance. So we're still in the do not reject H0. So now see, it says at the end of the semester, the proportion in the students in the top 20% of the class was determined. Of the students in group 1, 28% were in the top 20. What does it have? It's got a little. Oh, that's handy. Expected to be in the top 20 if no one. If C location doesn't pay a roll, this one should be 20 across the board. They changed it up. So H0 should be it's 20% in each group because it would be the same amongst the groups. And HA is that it would not be the same amongst the groups. For me, that's C. It might be different for you. Here, we're going to do compute the p-value. I'm just going to use what they had. Stats, goodness of fit, chi-square. Observed is in percent in top 20. All cells in equal proportion is what they're saying. It should be equal. So I don't need to type them in. And I'm getting 0.0576 to 3 decimal places is 0.058. So my p-value is greater than alpha. So it's not too low. I do not reject H naught. I do not support HA. H naught should not be rejected because the p-value of the test is greater than the level of significance. That's it for that question. I'm gonna look at the others. I've already done over half for you. There's only 3 left to do. Six looks like a pain in the ass. We must verify the data come from a population that is normally distributed and the sample size does not contain any outliers. So this is going back. This is just doing a t-stat test real quick. The normal probability plot and box plot are shown. I don't see any outliers on the box plot, and this graph looks nice and pretty. The dots are all near the center line. So both conditions are met. Constructing 95% confidence interval. We're just gonna go stats, t-stats, one sample with data. And we're gonna give a confidence interval of 95%. And tell it where the data was located, column 1. Gives me 152.86. And 177.74. So this is number 6. You're doing a stats and a t-stats confidence interval. So what could be done to decrease the margin of error? The margin of error is related to the confidence interval. The higher the confidence level, the wider the margin of error. So if they want to decrease the margin of error, they have to decrease the level of confidence. That was it for number 6. All right, now I've done 5 out of 7 for you. Number 7 is what can be done if one of the categories doesn't match. I would increase the sample size or combine categories. There, now I've done 6 out of the 7. And I will save number 5 for you.